Dear students, in the last classes we were discussing adsorption isotherms. Today we will be discussing factors affecting adsorption. So, what are the factors which affects adsorption? There are 4 important factors that affect adsorption, namely nature of adsorbent, nature of adsorbate, temperature and pressure. So, factors of affecting adsorption. First one, nature of adsorbate. Second, nature of adsorbent. Next is temperature, and fourth one, pressure. So, these are the 4 important factors which affect adsorption. First one, nature of adsorbate molecules. So, more easily liquefiable gases, they adsorb rapidly, readily, easily liquefiable gases. Easily liquefiable gases adsorb readily. So, therefore, for adsorption to happen, more easily liquefiable gases adsorb readily on any adsorbent, whereas nature of adsorbent, so that is very important, surface area. If the surface area is more, surface area of the adsorbent is more, then adsorption will be more, because as the surface area increases, then more number of active sites on the surface will be more. Active sites means reaction sites, adsorption sites, that will be more. As the surface area increases, then adsorption also increases. So many metals in the finely divided state, they act as a good adsorbents, okay, because more the surface area, more will be the adsorption. Next we will move on to temperature. So, as we all know, as temperature increases, adsorption decreases, because in last class I have discussed adsorption isotherm. In that isotherm, as temperature increases, adsorption curve will be in the lower side, that means adsorption decreases. But for physisorption, adsorption occur at lower temperature. As temperature increases, adsorption decreases, okay. But in case of chemisorption, what happens is, as the temperature increases, adsorption also increases for a certain extent, because chemisorption means chemical bond formation takes place. For chemical reaction, there should be some minimum amount of heat. Therefore, as temperature increases, physisorption occurs at a lower temperature, whereas chemisorption occurs at higher temperatures. As temperature increases, physisorption decreases. As temperature increases, chemisorption increases for a certain extent. Afterwards, again chemisorption also decreases. So, that is how temperature affect on adsorption. Now, finally, last one, effect of pressure, as we all discussed in adsorption isotherm. As pressure increases, adsorption also increases. As pressure ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ adsorption ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. It is directly proportional. Pressure increases, adsorption also increases. That means pressure and adsorption is directly related. So, these are all the 4 important factors on which adsorption depends. So, afterwards factors affecting adsorption ಆದ ನಂತರ ನೆಕ್ಸ್ಟ್ ನಾವು ಅಡ್ಸಾರ್ಪ್ಷನ್ ಫೆನಾಮಿನನ್ನಲ್ಲಿ ಲಾಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ಗೆ ಹೋಗ್ತೀವಿ. ಸೊ ವಾಟ್ ಈಸ್ ದಟ್ ಲಾಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ ಅಂದರೆ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್. ಅಡ್ಸಾರ್ಪ್ಷನ್ನ ಅಪ್ಲಿಕೇಶನ್ ಏನೇನು ಅಂತ ನೋಡ್ತೇವೆ. Applications of adsorption. So we all know there are so many applications of adsorption are there, but ನಾನು ಇಲ್ಲಿ few applications ಮಾತ್ರ ಲಿಸ್ಟ್ ಔಟ್ ಮಾಡ್ತೇನೆ. So we will see. Application number 1, to create high vacuum. high vacuum create ಮಾಡಲಿಕ್ಕೆ adsorption processನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. So first application is to create high vacuum. Application number 2, that is in gas masks. Gas masks alli this phenomenon of adsorption na applicable agutte, applicable ಮಾಡ್ತಾರೆ. Next, third one, in heterogeneous catalysis. Heterogeneous catalysis. Heterogeneous catalysis alli this phenomenon of adsorption na use ಮಾಡ್ತೇವೆ. ನೆಕ್ಸ್ಟ್ ನಾಲ್ಕನೇದು ಫಾರ್ ಕಂಟ್ರೋಲಿಂಗ್ ಹ್ಯುಮಿಡಿಟಿ. ಹ್ಯುಮಿಡಿಟಿ ಕಂಟ್ರೋಲ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದೆನ್ ಫಿಫ್ತ್ ಒನ್ ಫಾರ್ ದ ರಿಮೂವಲ್ ಆಫ್ ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್. ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್ ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ಗೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಡುವಾಗ ಹೇಳಿದ್ದೇನೆ. ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್ನ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಕೂಡ ಈ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಫೆನಾಮಿನನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಹಾಗೆ ಇನ್ನೂ ತುಂಬಾ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಇದೆ. ಬಟ್ ಇನ್ ದಿ ಎಕ್ಸಾಮಿನೇಷನ್ ದೇ ವಿಲ್ ಆಸ್ಕ್ ರೈಟ್ ಎನಿ ಒನ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಲೈಕ್ ದಟ್. ಸೊ ಅದರಿಂದ ನೀವು ಯಾವುದಾದ್ರೂ ಒಂದು ಅಥವಾ ಎರಡು ಅಪ್ಲಿಕೇಶನ್ಸ್ನ ನೆನಪಿನಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ಸಾಕಾಗುತ್ತೆ. ಸೊ ಫಸ್ಟು ಒನ್ ಬೈ ಒನ್ ಈಗ ನೋಡೋಣ. ಟು ಕ್ರಿಯೇಟ್ ಹೈ ವ್ಯಾಕ್ಯೂಮ್. ಹೈ ವ್ಯಾಕ್ಯೂಮ್ ಕ್ರಿಯೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಫೆನಾಮಿನನ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಹೌ? ದಟ್ ಮೀನ್ಸ್ trace quantity of gas molecules present in the vacuum can be removed by placing charcoal into the vacuum. Therefore, we will get high vacuum. That is one of the important application of adsorption. Next, second one, in gas masks. Gas masks alli traffic police gas mask ಹಾಕಿರ್ತಾರೆ, ಅಂದರೆ ಪಾಯ್ಸನಸ್ ಗ್ಯಾಸಸ್ನ ಇನ್ಹೇಲ್ ಮಾಡಬಾರ್ದು ಅಂತ. ಲೈಕ್ ದಟ್ ಇನ್ ಕೋಲ್ ಮೈನಿಂಗ್. ಕಲ್ಲಿದ್ದಲು ಗಣಿಗಾರಿಕೆ ಮಾಡುವಾಗ ದೇರ್ ಆರ್ ಸೋ ಮೆನಿ ಪಾಯ್ಸನಸ್ ಗ್ಯಾಸಸ್ ಎಮಿಟಿಂಗ್. ಸೊ ಟು ಪ್ರಿವೆಂಟ್ ಫ್ರಮ್ ದೋಸ್ ಪಾಯ್ಸನಸ್ ಗ್ಯಾಸಸ್ ದೇ ವಿಲ್ ಯೂಸ್ ಗ್ಯಾಸ್ ಮಾಸ್ಕ್. ಗ್ಯಾಸ್ ಮಾಸ್ಕಲ್ಲಿ ದೇರ್ ವಿಲ್ ಬಿ ಎ ಲೇಯರ್ ಆಫ್ ಅನಿಮಲ್ ಚಾರ್ಕೋಲ್. ಸೊ ದಟ್ ಚಾರ್ಕೋಲ್ absorbs poisonous gases and only give pure oxygen for inhaling. Therefore, due to that adsorption phenomenon, this gas mask works. So this gas mask absorbs poisonous gases, whereas only pure oxygen get inside. So that is another application. Next, in case of heterogeneous catalysis, see here in P block elements, ನೀವು ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿರ್ತೀರಾ. P block elements ಅಲ್ಲಿ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಅಮೋನಿಯಾ ಬೈ ಹೇಬರ್ ಪ್ರೋಸೆಸ್, ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬೈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಪ್ರೋಸೆಸ್, ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಬೈ Ostwald's process, all those processes are catalytic reactions. So heterogeneous catalytic reactions. So those heterogeneous catalytic reactions alli we will use catalyst, that is the substance which alters the rate of a chemical reaction, catalyst. So catalyst is a substance that alters the rate of a chemical reaction. So aa catalyst na use ಮಾಡ್ತೀವಿ. So that catalyst ಮೇಲೆ reactants reaction ಆಗಿ chemical reaction ಆಗಿ ನಮಗೆ products ಬರ್ತದೆ. ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಅಮೋನಿಯಾ ಬೈ ಹೇಬರ್ಸ್ ಪ್ರೊಸೆಸ್ಸಲ್ಲಾಗಲಿ, ಸಲ್ಫ್ಯೂರಿಕ್ ಆಸಿಡ್ ಬೈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಪ್ರೊಸೆಸ್ ಆಗಲಿ, ಹಾಗೆ ಆಸ್ವಾಲ್ಡ್ಸ್ ಪ್ರೊಸೆಸ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಆಗಲಿ, ಆಲ್ ದೋಸ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆರ್ heterogeneous catalytic reactions. There adsorption phenomenon plays a very important role. Industry important compounds manufacturer ella kuda adsorption phenomenon a vital role is there. So therefore adsorption phenomenon is very very important. Next nodi illi to control humidity control ಮಾಡಲಿಕ್ಕೆ ಅಂತ ಹೇಳ್ತೀವಿ. What do you mean by humidity? Humidity ಅಂದ್ರೆ ಏನು? Humidity means it is nothing but the water vapors present in the atmosphere. So ವಾತಾವರಣದಲ್ಲಿರುವಂಥ ತೇವಾಂಶ, ಆ ತೇವಾಂಶನ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ವಾಟರ್ ವೇಪರ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ atmosphere, those water vapors are removed by adsorption. ಹೇಗೆ? When silica gel is placed in the atmosphere, the water vapors are get adsorbed on the surface of silica gel, then humidity controls. So more number of water vapors iddre humidity ಜಾಸ್ತಿ ಇರುತ್ತೆ. So to control humidity we will use silica gel as adsorbent. So therefore controlling of humidity is done by adsorption phenomenon. ಅದೇ ರೀತಿ ರಿಮೂವಿಂಗ್ ಆಫ್ ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್ಸ್ ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ ರಿಮೂವಿಂಗ್ ಆಫ್ ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್ಸ್ ಅಂತ ಹೇಳಿದಾಗ ಇಫ್ ಯು ಟೇಕ್ ರಾ ಶುಗರ್ ತಗೊಂಡಾಗ ಸೊ ದಟ್ ರಾ ಶುಗರ್ ಈಸ್ ಕಲರ್ಡ್. ಅಂದರೆ ನೀವು ಮನೇಲಿ ಯೂಸ್ ಮಾಡ್ತಿರಲ್ಲ ಸಕ್ಕರೆ, ಆ ಸಕ್ಕರೆಗಿಂತ ತುಂಬ ಡಿಫ್ರೆಂಟಾಗಿ ಕಲರ್ ಇರುತ್ತೆ, ವೈಟ್ ಕಲರ್ ಇರೋದಿಲ್ಲ. ಸೊ ಆ ಕಲರ್ ನೋಡಿದರೆ ನೀವು ಆ ಸಕ್ಕರೆನ ಯೂಸೇ ಮಾಡೋದಿಲ್ಲ. ಸೊ ದಟ್ ರಾ ಶುಗರ್ ಈಸ್ ಮೋರ್ ಕಲರ್ಡ್. ಫಾರ್ ದ ರಿಮೂವಲ್ ಆಫ್ ದಟ್ ರಾ ಶುಗರ್ ದೇ ವಿಲ್ ಯೂಸ್ ಅನಿಮಲ್ ಚಾರ್ಕೋಲ್, ಬೋನ್ ಪೌಡರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಅನಿಮಲ್ ಚಾರ್ಕೋಲ್ನ ಯೂಸ್ ಮಾಡಿ ದೇ ಆರ್ ರಿಮೂವಿಂಗ್ ದ ಕಲರ್ ಆಫ್ ಶುಗರ್. ಸೊ ದೇರ್ ಫೋರ್ ನೌ ವಿ ಗೆಟ್ ಕ್ಲಿಯರ್ ಶುಗರ್, ವೈಟ್ ಕಲರ್ ಶುಗರ್. ಸೊ ದಟ್ ಈಸ್ removing of color by animal charcoal. So nowadays that color of sugar is removed by using sulfur. ಮೊದಲೆಲ್ಲ ಶುಗರ್ನ ಪ್ಯೂರಿಫೈ ಮಾಡಲಿಕ್ಕೆ, ಆ ಒಂದು ಕಲರಿಂಗ್ ಮ್ಯಾಟರ್ನ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ದೇ ಆರ್ ಯೂಸಿಂಗ್ ದಿಸ್ ಅನಿಮಲ್ ಚಾರ್ಕೋಲ್. ಬಟ್ ನವೇಡೇಸಲ್ಲಿ ಸಲ್ಫರ್ನ ಕಲರ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ದೇರ್ ಫೋರ್ ದಟ್ ಈಸ್ ಅನದರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ the some important applications uses of adsorption. So you should remember any one or any two. In the examination they will ask one or more applications of adsorption phenomenon. This is all about one part of the surface chemistry. So first part adsorption part mugitu. So now next second part ide, that is nothing but colloid. So now we will move on to the second part of the surface chemistry, that is colloids. So what are these colloids? Colloids andrenu? Colloids are the heterogeneous system in which one substance is dispersed in another substance. That is called colloid. Colloid means it is an heterogeneous system in which one substance is dispersed in another substance. ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸು ಮತ್ತೊಂದು ಸಬ್ಸ್ಟೆನ್ಸಲ್ಲಿ ಡಿಸ್ಪರ್ಸ್ ಆಗಿದ್ದರೆ ಅದನ್ನು ಕಲಾಯ್ಡ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಒನ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಡಿ ಪಿ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ ಡಿಸ್ಪರ್ಷನ್ ಫೇಸ್. ಆ್ಯಂಡ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಇನ್ ಅನದರ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳಿದೆ. ಸೊ ದಟ್ ಅನದರ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಟಿ ಎಮ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ dispersion medium. So one substance dispersion phase is dispersed in another substance dispersion medium. So if you take a colloidal system anta tagondre, in that colloidal system there will be two substances. One will be dispersion phase and another will be dispersion medium. So what is dispersion phase hagadre? What do you mean by dispersion medium? Dispersion phase, DP, dispersion phase means the substance which is present in smaller quantity. Yava substance smaller quantity alli irutto, the substance which is present in smaller quantity, that is called dispersion phase and the substance present in larger quantity is called dispersion medium. So, smaller quantity irodu, it is discontinuous, whereas larger quantity irodu, it is continuous. See here, colloidal system consists of two substances, dispersion phase and dispersion medium. Dispersion phase is a discontinuous phase containing colloidal particles having smaller quantity. Dispersion medium, it is a continuous phase containing colloidal particles in which present in larger quantity. Adanna dispersion phase and dispersion medium anta karitivi. So, as we know, substances are of three types. Substances alli mooru type ide. What are those three types of substances? One is crystalloid. Crystalloid, also called as true solution particle. Another one is colloid, what we are discussing now, and the third one is suspension. So, these are the three types of substances present in nature. Okay? Crystalloid are true solution particles, colloids are suspensions. For example, crystalloids are very small, we can't see through naked eye, whereas colloid is little bigger and suspensions are more bigger, you can see through naked eye. So, based on the particle size, they have divided these three kinds of substances. How? If the particle size is 1 to 1000 nanometer, if the particle size is 1 to 1000 nanometer, then that is called colloid. If the particle size is greater than 1000 nanometer, then such particles are called suspensions. If the particle size is less than 1 nanometer, then such type of particles are called crystalloids or true solution. So, now you can define colloids as the substances in which the particle sizes range from 1 to 1000 nanometer, or the colloids are the substances in which the particle size is intermediate between crystalloids or true solution particles and suspensions. So, now based on the particle size now colloids define madodadre, these are the substances in which the particle sizes range from 1 to 1000 nanometers. So, they are called as colloids. Now, these are all about the introduction of colloids. Next, go for types of colloids. So, colloids are classified based on three different ways. ಮೂರು ಬೇರೆ ಬೇರೆ ರೀತಿಯಲ್ಲಿ colloids na classify ಮಾಡಿದ್ದಾರೆ. So, what are those three different ways of classification? One by one we will discuss. One, classification based on the physical state of dispersion phase and dispersion medium. Based on physical state, of dispersion phase and dispersion medium. So, based on the physical state, colloids are classified into 8 types. Okay. ಅಂದರೆ ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ನ ಬೇಸಿಸ್ ಮೇಲೆ ಕಲಾಯ್ಡ್ಸ್ನ 8 ಟೈಪ್ಸ್ ಆಗಿ ಕ್ಲಾಸಿಫೈ ಮಾಡಿದ್ದಾರೆ ಬೇಸ್ಡ್ ಆನ್ ದ ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ ಆಫ್ ಡಿಸ್ಪರ್ಷನ್ ಫೇಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್. ಸೆಕೆಂಡ್ ವೇ ಆಫ್ ಕ್ಲಾಸಿಫಿಕೇಷನ್ ಏನಪ್ಪ ಅಂದರೆ ಬೇಸ್ಡ್ ಆನ್ ದ interaction between dispersion phase and dispersion medium. Dispersion phase ಮತ್ತು dispersion medium ಮಧ್ಯ based on the interaction, colloids are classified into 2 types based on the interaction between dispersion phase and dispersion medium. Dispersion phase ಮತ್ತು dispersion medium ನ interaction basis ಮೇಲೆ there are two types. ಹಾಗೇನೆ ಮೂರನೇ classification, third one, based on the nature or type of the particle present, based on the type of particles present, colloids are classified into three types. So, this is the classification of colloid. Colloids are classified based on three different ways. First one, based on the physical state of dispersion phase and dispersion medium, there are 8 types in colloid. ಅದೇ ರೀತಿ based on the interaction between dispersion phase and dispersion medium, there are 2 types. Similarly, based on the type of particle present, colloidal system, colloids are classified into 3 types. Now one by one ನೋಡೋಣ. First one, based on the physical state of dispersion phase and dispersion medium, there are 8 types. What are those 8 types ಅಂತ ನೋಡೋಣ. Based on the physical state. ನಾವು ಒನ್ ಬೈ ಒನ್ ಲಿಸ್ಟ್ ಮಾಡ್ತಾ ಹಾಗೆ ನೋಡ್ಕೊಂಡು ಹೋಗೋಣ ಎಕ್ಸಾಂಪಲ್ಸು. ಸೊ ಫಸ್ಟು ಡಿಸ್ಪರ್ಷನ್ ಫೇಸ್ ಬರೀತೇನೆ ನಾನು, ಮತ್ತು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ ಬರೀತೇನೆ, ಹಾಗೆಯೇ ಕಲಾಯ್ಡಲ್ ಸಿಸ್ಟಮ್ ಅಂದರೆ ಕಲಾಯ್ಡ್ ಯಾವುದು ಅಂತ ಹೆಸರು ಹೇಳ್ತೇನೆ, ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸು ಬರೆಯೋಣ. See, first, if the dispersion phase is solid and dispersion medium is also solid, if both are solids, then that colloidal system is called as solid sol. That colloidal system is called as solid sol. That means solid dispersed in solid. Examples ಏನಂದರೆ some colored glasses, colored glasses, ಹಾಗೆ ruby stone and gems, ruby glass and gemstone. Some colored glasses, gemstones, etc. Gemstones ಅಂದರೆ ನೀವು ರಿಂಗಲ್ಲೆಲ್ಲ ಹಾಕಿರ್ತೀರಲ್ಲ, ಸೊ ಅದು gemstone ಅಂತ ಕರಿತೀವಿ. ಮತ್ತು so many colored glasses are there. ಮತ್ತು ಇನ್ನು alloy ಕೂಡ alloys, they are also solid sol. That means solid is dispersed in solid. Next, second one, if solid dispersion phase and liquid dispersion medium, then colloid is called as sol. Then sol anta karitivi. So solid dispersed in solid, that is called sol. Example, paints, paint is an example. ಹಾಗೆ ನೀವು ಬಯಾಲಜಿಲಿ ಓದಿರ್ತೀರ ಸೆಲ್ ಫ್ಲೂಯಿಡ್ಸ್, ಪೇಂಟ್ಸ್ ಆ್ಯಂಡ್ ಸೆಲ್ ಫ್ಲೂಯಿಡ್ಸ್, ಇನ್ನು ಬೇರೆ ಬೇರೆ ಎಕ್ಸಾಂಪಲ್ಸ್ ಇದೆ. ಸೊ ಇದು ಸಾಕು. ಸೊ ಪೇಂಟ್ ಆ್ಯಂಡ್ ಸೆಲ್ ಫ್ಲೂಯಿಡ್ಸ್, ದಟ್ ಈಸ್ ಸಾಲಿಡ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಇನ್ ಲಿಕ್ವಿಡ್. ಮೂರನೇದು, ಥರ್ಡ್ ಒನ್, ಸಾಲಿಡ್ ಡಿಸ್ಪರ್ಸ್ಡ್ ಇನ್ ಗ್ಯಾಸ್, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆ್ಯಕ್ಚುಲಿ ಏರೋಸಾಲ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇದು ಸಾಲಿಡ್ ಏರೋಸಾಲ್, ಯು ಕ್ಯಾನ್ ಕಾಲ್ ದಟ್ ಆಸ್ ಸಾಲಿಡ್ ಏರೋಸಾಲ್, ಸಾಲಿಡ್ ಏರೋಸಾಲ್ ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸು ಸ್ಮೋಕ್ ಇದೆ, ದಟ್ ಈಸ್ ಸಾಲಿಡ್ ಏರೋಸಾಲ್, ಡಸ್ಟ್ ದಟ್ ಈಸ್ ಸಾಲಿಡ್ ಏರೋಸಾಲ್, ಹಾಗೆ ದಟ್ ಈಸ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಸಾಲಿಡ್ ಏರೋಸಾಲ್. ಸ್ಮೋಕ್ ಅಂದರೆ ದಟ್ ಈಸ್ ಕಾರ್ಬನ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇನ್ ಏರ್. So carbon particle is dispersion phase and air is dispersion medium. So therefore that is solid dispersed in air. Therefore this is solid aerosol. Next, fourth one, if dispersion phase is liquid, if you take dispersion phase as liquid and dispersion medium as solid, Now that colloidal system is called gel. So adana gel anta karitivi. Adakke examples all of you know jellies, hagene cheese ide, butter ide. So all those are gels. And then if liquid dispersed in liquid, dispersed in liquid, then that is called as emulsion. This is a well known concept, emulsion. Liquid dispersed in liquid, then that is called as emulsion. Nimge ellargu gottide, daily use ಮಾಡ್ತೀರಾ, that is milk. Milk is an emulsion. Like that, blood, ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ blood ಇದೆ, that is also emulsion. And then next, if dispersion phase is liquid and dispersion medium is gas, this is also called as aerosol, but ಇಲ್ಲಿ liquid aerosol ಅಂತ ಕರೆಯೋಣ. Liquid aerosol ಎಕ್ಸಾಂಪಲ್ಸ್ ಏನಂತಂದರೆ, ನೀವು ಬೆಳಗಿನ ಜಾವ ಎದ್ದಿದ್ರೆ ಹೊರಗಡೆ ನೋಡಿದರೆ ಪ್ಲ್ಯಾಂಟ್ಸ್ ಮೇಲೆ, ಎಲೆಗಳ ಮೇಲೆಲ್ಲ ಡ್ರಾಪ್ಲೆಟ್ಸ್ ಬಿಟ್ಟಿರುತ್ತೆ, ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ಸ್. ಲೈಕ್ ದಟ್ ಮಿಸ್ಟ್ ಇದೆ, ಹಾಗೆ ಫಾಗ್ ಇರುತ್ತೆ, ಹಾಗೆ ಕ್ಲೌಡ್ಸ್ ಗೊತ್ತಿದೆ ಅಲ್ಲ, ಕ್ಲೌಡ್ಸ್. ಸೊ ಅದೆಲ್ಲ ಕೂಡ ಲಿಕ್ವಿಡ್ ಏರೋಸಾಲ್ಸ್, ಅಂದರೆ ಲಿಕ್ವಿಡ್ಡು ಗ್ಯಾಸಲ್ಲಿ ಡಿಸ್ಪರ್ಸ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಲಿಕ್ವಿಡ್ ಏರೋಸಾಲ್. ಎಕ್ಸಾಂಪಲ್ ಮಿಸ್ಟು, ಫಾಗು, ಕ್ಲೌಡ್ಸ್ ಎಕ್ಸೆಟ್ರಾ. ನೆಕ್ಸ್ಟ್ 5, 6 ಆಯಿತು. ನೆಕ್ಸ್ಟ್ 7th ಟೈಪ್ ಈಸ್ ಇಫ್ dispersion phase is gas and dispersion medium is solid, then that is called as solid foam. Solid foam anta ಕರೀತೀವಿ. and solid foam ಗೆ ಎಕ್ಸಾಂಪಲ್ ಏನಪ್ಪ ಅಂದರೆ ಫೋಮ್ ರಬ್ಬರ್ ಅಂತ ಇದೆ, ಹಾಗೆ ಪೂಮೈಸ್ ಸ್ಟೋನ್ ಅಂತ ಇದೆ. ಪೂಮೈಸ್ ಸ್ಟೋನ್ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದರೆ ಸ್ಕಿನ್, ಡ್ರೈ ಸ್ಕಿನ್ ಎಲ್ಲ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಪೂಮೈಸ್ ಸ್ಟೋನ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ದಟ್ ಈಸ್ ಸಾಲಿಡ್ ಫೋಮ್, ದಟ್ ಮೀನ್ಸ್ ಗ್ಯಾಸ್ ಡಿಸ್ಪೋಸ್ಡ್ ಇನ್ ಸಾಲಿಡ್. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಸಾಲಿಡ್ ಫೋಮ್. ಎಕ್ಸಾಂಪಲ್ಲು ಫೋಮ್ ರಬ್ಬರ್ ಆ್ಯಂಡ್ ಪೂಮೈಸ್ ಸ್ಟೋನ್. ಆ್ಯಂಡ್ 8th one, gas dispersed in liquid. So if gas dispersed in liquid, then that is called foam. ಸೊ ದಟ್ ಈಸ್ ಫೋಮ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ಸು ಫ್ರಾತ್ ಇಸ್ ಎ ಫೋಮು, ದೆನ್ ಸೋಪ್ ಲ್ಯಾದರ್, ದಟ್ ಈಸ್ ಫೋಮ್, wiped creams, that is foam. Like that you can give so many examples for foam. See here, these are the 8 types based on the physical state of dispersion phase and dispersion medium. ಸೊ ಕಲಾಯ್ಡ್ಸಲ್ಲಿ 8 ಟೈಪ್ ಇದೆ. ಇನ್ನೊಂದು ನೋಡಿ, ಗ್ಯಾಸ್ ಆ್ಯಂಡ್ ಗ್ಯಾಸು ಡಸ್ ನಾಟ್ ಎಕ್ಸಿಸ್ಟ್. ಯಾಕೆ ಅಂತಂದರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ಕಲಾಯ್ಡ್ಸ್ ಶುಡ್ ಬಿ ಹೆಟ್ರೋಜಿನಿಯಸ್, ವೆರಾಸ್ ಗ್ಯಾಸ್ ಆ್ಯಂಡ್ ಗ್ಯಾಸ್ ಮಿಕ್ಸ್ ಆದರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಫಾರ್ಮ್ಸ್ ಹೋಮೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್. ಸೊ ಇಫ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಹೋಮೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್, ದೆನ್ colloidal solution formation does not takes place. Therefore gas and gas dispersion phase and dispersion medium not be there. So therefore only 8 types of colloids are there based on the physical state of dispersion phase and dispersion medium. Followed all of you? So in examination they will ask what is gel, what is emulsion, what is sol. Give an example. Like that they will ask. That means, or which is the dispersion phase present in gel, which is the dispersion medium present in sol. Like that they will ask any question in this. Okay. So therefore you should remember the examples also. They will ask for examples. Okay. So this is one type of classification. Next, go for second. What is that? Based on the interaction between dispersion phase and dispersion medium, lyophilic colloid and lyophobic colloid. These are the two types of colloids based on the interaction between dispersion phase and dispersion medium. So, see here, this is lyophilic. Philic means attractive anta, loving anta. So, here lyophilic colloid means they are solvent loving colloids, and phobic means, that is phobia anta heltivalla. So, hating anta, solvent hating colloids. What is the meaning of that? Solvent loving colloids are lyophilic colloids, solvent hating colloids are lyophobic colloids. So, solvent loving colloid means in case of lyophilic colloid, there will be strong interaction between dispersion phase and dispersion medium. Dispersion phase matte dispersion medium madhya there will be an interaction. So, that is strong interaction between dispersion phase and dispersion medium. Okay. But in case of lyophobic colloids, there is no interaction between dispersion phase and dispersion medium. Lyophobic colloids alli dispersion phase ಮತ್ತು dispersion medium ನಡುವೆ there are no interactions, whereas in case of lyophilic colloids, so there is a strong interaction between dispersion phase and dispersion medium. So, what are lyophilic and lyophobic colloids anta examination alli kelbodu, or even they may ask write any two differences between lyophilic and lyophobic colloids. ನಿಮಗೆ ಈ ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಕೇಳುವಾಗ ಆಲ್ಮೋಸ್ಟ್ 3 differences ಕೇಳಬಹುದು. 3 differences ಯಾವ್ದಾವ್ದ್ರದ್ದು ಅಂತ ಅಂದರೆ, ಫಸ್ಟ್ ಒನ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆ್ಯಂಡ್ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಒಂದು, ಅದೇ ರೀತಿ ಸೆಕೆಂಡ್ ಒನ್ ಫಿಸಿಸಾರ್ಪ್ಷನ್ ಆ್ಯಂಡ್ ಕೆಮಿಸಾರ್ಪ್ಷನ್ ಡಿಫರೆನ್ಸ್ ಕೇಳ್ಬೋದು, ಅದೇ ರೀತಿ ಲಯೋಫಿಲಿಕ್ ಕಲಾಯ್ಡ್ ಆ್ಯಂಡ್ ಲಯೋಫೋಬಿಕ್ ಕಲಾಯ್ಡ್ಗೂ ಡಿಫರೆನ್ಸ್ ಕೇಳ್ಬೋದು. ಸೊ ಆ ಮೂರಲ್ಲಿ ಒಂದು ಡಿಫರೆನ್ಸ್ ನಿಮಗೆ ಎಕ್ಸಾಮಲ್ಲಿ ಕೇಳ್ತಾರೆ. ಸೊ ದೇರ್ ಫೋರ್ ದಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಲಯೋಫಿಲಿಕ್ ಆ್ಯಂಡ್ ಲಯೋಫೋಬಿಕ್ colloids. So, what are the difference between lyophilic and lyophobic colloids? Andre one difference, they are solvent loving, lyophobic solvent hating. Lyophilic colloid, there is interaction between dispersion phase and dispersion medium. In lyophobic colloid, there is no interaction between dispersion phase and dispersion medium. Then another difference is lyophilic colloids are stable because of strong interaction, whereas lyophobic colloids are unstable. Lyophobic colloids, so they are unstable because there is no interaction between dispersion phase and dispersion medium. Next difference ಆದರೆ lyophilic colloids can be reversed. Lyophilic colloids colloidal solution formation ಆದ ಮೇಲೆ you can separate those dispersion phase and dispersion medium. Once again they form colloidal solution. So therefore lyophilic colloid is reversible in nature, whereas lyophobic colloids, so they are not having any interaction, therefore they are irreversible. Lyophobic colloids, so they are irreversible in nature. So any two difference in the examination, they will ask write any two differences between lyophilic and lyophobic colloids. So ಅದರಲ್ಲಿ ನಾನು ಇಲ್ಲಿ 4 ಡಿಫರೆನ್ಸಸ್ ಬರೆದಿದ್ದೀನಿ. ಇನ್ನು ಯು ಕ್ಯಾನ್ ರೈಟ್ ಸೋ ಮೆನಿ ಡಿಫರೆನ್ಸ್, ಬಟ್ ಎನಿ ಟು ಡಿಫರೆನ್ಸಸ್ ಸಾಕಾಗಿರೋದ್ರಿಂದ ಇಷ್ಟು ಡಿಫರೆನ್ಸ್ ನಿಮಗೆ ಸಾಕಾಗುತ್ತೆ. ಹಾಗೆ ಒಂದೊಂದು ಎಕ್ಸಾಂಪಲ್ ನೀವು ಕೊಡ್ಬೋದು ಡಿಫರೆನ್ಸಸ್ಸಲ್ಲಿ. ಯು ಕ್ಯಾನ್ ಗಿವ್ ಸಮ್ ಎಕ್ಸಾಂಪಲ್ಸು. ಲಯೋಫಿಲಿಕ್ ಕಲಾಯ್ಡ್ಸ್ಗೆ ಎಕ್ಸಾಂಪಲ್ಸು ಸ್ಟಾರ್ಚ್ ಸಾಲು, ಹಾಗೆಯೇ ಪ್ರೋಟೀನ್ ಸಾಲ್, cellulose, protein salt, etc. etc. they are lyophilic salts. ಅದೇ ರೀತಿ lyophobia salts ಗೆ you can give gold salt, ಹಾಗೆ silver salt, platinum salt, silver salt, etc. etc. sulfur salt, like that. You can give so many examples for lyophobic colloids. So if in this lyophilic or lyophobic colloids, if solvent is water, then this is also called as hydrophilic colloid and this is also called as hydrophobic colloid. When yavaga hydrophilic and hydrophobic anta karitivi andre only when if the solvent is water. So, that is hydrophilic and hydrophobic colloids anta karitivi. So, this is second way of classification of colloids based on the interaction between dispersion phase and dispersion medium. There are two types, okay, lyophilic and lyophobic. Followed all of you? So, next we will move on to third way of classification. So, yavadu moornedu? Based on the type of particles present. Third way of classification. Based on the type of particles present, there are three types. Based on the type of particles, there are three types are there. What are those three types? Namely, first one, multimolecular colloid. Multimolecular colloid. Second one, macromolecular colloid. And moornedu, associated colloids. So, multimolecular colloid, macromolecular colloid and associated colloid. Okay. These are all the three different types of colloids. So, based on the nature or type of the particles present in the colloid. So, iga multimolecular colloid andrenu? What do you mean by multimolecular colloid? What is macromolecular colloid? What is associated colloid? Nodana. So, multimolecular colloid means on dilution large number of atoms and smaller molecules undergo aggregation to form solution of colloidal size particles. So, that means multimolecular colloid alli large number of atoms and smaller molecules, they undergo aggregation, grouping agutte, aggregation agutte. So, undergo aggregation to form a colloidal solution. So, a multimolecular colloids alli they are lyophobic colloids. So, multimolecular colloids they are lyophobic. So, they are lyophobic agirodrinda they are unstable, as lyophobic colloids are unstable. So, lyophobic colloids they are lyophobic colloids, that is multimolecular colloids are lyophobic in nature, then therefore they are unstable. Examples yavudyavudu anta helidre sulfur sol. So, sulfur sol is multimolecular colloid. Yakendre ee sulfur sol alli this sulfur sol contains 1000 or above 1000 molecules of S8. So, 1000 and above 1000 molecules irutte, S8 molecules yavadralli sulfur sol alli. So, therefore, that is multimolecular colloid anta karitivi. So, next macromolecular colloid anta ide. So, what do you mean by macromolecular colloid? Macromolecules in a suitable solvent forms a solution with particles of colloidal size. Andre macromolecules andre like protein, cellulose, like that. Okay, that is polystyrene, that is synthetic rubber. All those things are macromolecules. Those macromolecules in a suitable solvent forms a solution in which the particle size is of colloids. So, they are macromolecular colloids. So, macromolecular colloids alli ಎರಡು ಪಾರ್ಟ್ ಇದೆ. ಒಂದು ನ್ಯಾಚುರಲಿ ಅಕ್ಕರಿಂಗ್ ಮ್ಯಾಕ್ರೋಮಾಲಿಕ್ಯೂಲು, ಮತ್ತೊಂದು ಸಿಂಥೆಟಿಕ್ ಮ್ಯಾಕ್ರೋಮಾಲಿಕ್ಯುಲರ್ colloid. So, naturally occurring macromolecular colloid and synthetic macromolecular colloid ಎರಡಿದೆ. ನ್ಯಾಚುರಲಿ ಅಕ್ಕರಿಂಗ್ ಮ್ಯಾಕ್ರೋಮಾಲಿಕ್ಯುಲರ್ colloidಗೆ ಎಕ್ಸಾಂಪಲ್ಲು ಪ್ರೋಟೀನು, cellulose, starch, ಇದೆಲ್ಲ salts, protein salt, cellulose salt, starch salt, these are all naturally occurring macromolecular colloid, whereas synthetic macromolecular colloids ಯಾವ್ದು ಅಂದರೆ that is synthetic rubber, polystyrene, etc. So, they are synthetic macromolecular colloids. So macromolecular colloids alli synthetic macromolecular colloids ide and naturally occurring macromolecular colloids ide, adakke examples. So next, associated colloids. So what are these associated colloids? Are the substances which behaves as strong electrolytes at normal concentration and they behaves as a colloid at higher concentration. So at higher concentration the molecules undergo aggregation to form micelle. So the formation of micelle takes place only above certain temperature called Kraft temperature, Tk, Kraft temperature. And CMC means critical micelle concentration. So CMC is critical micelle concentration. So above Kraft temperature and above critical micelle concentration, this associated colloids or micelle formation takes place. So that is CMC, critical micelle concentration, and Tk, Kraft temperature. So the temperature at which micelle formation takes place, above which micelle formation takes place, concentration above which micelle formation takes place. So these are the two important concepts in associated colloids. Now what is associated colloid? These are the substances which behaves as a strong electrolyte at normal concentration and behaves as a colloids at higher concentration due to the formation of aggregates. So those aggregates are called as micelles. This micelle formation takes place only above certain temperature called Kraft temperature and above certain concentration called critical micelle concentration. So this is about associated colloids. So now that there are some surface active agents. Surface active agents are also called as surfactants. Surface active agents or surfactants, they can be the examples of associated colloids. What are those surface active agents or surfactants? They are soaps and detergents. You can take example of soap and detergent. Soaps and detergents. These are called as surfactants or surfactive agents. Now for soap, critical micelle concentration, CMC for soap, critical micelle concentration for soap is 10 power minus 3 to 10 power minus 4 mole per liter. So that is the CMC value, critical micelle concentration value for soap. So soap and detergents are the associated colloids. So this is all about associated colloids. Next we will discuss the mechanism of micelle formation, how micelle formation takes place ಅಂತ next ನಾವು ನೋಡೋಣ. Mechanism of micelle formation. So micelle formation ನ mechanism explain ಮಾಡಲಿಕ್ಕೆ we have to take soap. Okay, what do you mean by soap? Soap ಅಂದರೆ ನೀವು ಬಯಾಲಜಿಲೆಲ್ಲ ಓದಿರ್ತೀರಾ. What is the definition of soap? Soap ಅಂದರೆ that is the sodium or potassium salts of long chain fatty acids ಅಂತ ಕರಿತೀವಿ. Sodium or potassium salts of long chain fatty acids are called soaps. Okay, now we will take an example of sodium stearate. ಸೋಡಿಯಂ ಸ್ಟೀರೇಟ್ ಅನ್ನು ಎಕ್ಸಾಂಪಲ್ ಆಗಿ ತಗೊಳ್ಳೋಣ. So the molecular formula of sodium stearate is C17H35COO minus Na. This is sodium stearate. This sodium stearate has negative part and positive part. In solutions, this sodium stearate undergo ionization forming that is C17H35COO minus plus Na plus. That means in solution undergo dissociation in solution, water or in solution. So now consider this negative part here. So this is a stearate ion. The negative part is a stearate ion. So this stearate ion possesses two different parts. What are those two parts? One part is long chain hydrocarbon part and another part is COO minus group part. So long chain hydrocarbon part, this is hydrophobic. That means water repellent part, whereas this negative part is hydrophilic part. So long chain hydrocarbon is hydrophobic part and CO minus group is hydrophilic part. Therefore this long chain hydrocarbon that is called as tail. That means non-polar because there is no polar nature there. So non-polar tail and this is polar head. So we will write like this. So non-polar tail is this one and this is polar head. So because this is a long chain of hydrocarbon, see CH3 CH2 17 is there. So 16 COO minus. So this is tail and this is head. So because of this polar nature, it is hydrophilic. This is non-polar nature. Therefore this is hydrophobic in nature. Normal conditions of concentration, see, at normal concentration, what happens is this hydrophilic part, that means hydrophilic part na ನಾವು ಈ ಥರ ಬರಿತೀವಿ. So this is negative part and this is polar. This is polar part and this is non-polar part. So here in this solution at normal concentration, polar part will be with the water molecule and non-polar part will be outside the water molecule. Because why they are directed outside the water? Because they are water repelling, hydrophobic, and these are negative parts, polar heads, they directed inward to the water molecule under normal condition. Whereas at CMC what happens? At critical miscellaneous concentration, all these hydrophobic parts, tails, they undergo aggregation to form a spherical shape in which the hydrophobic part is directed towards the center of the sphere. All hydrophobic parts are directed towards the center of sphere. So this is water will be there. See here, this aggregation of positive part or hydrophobic part like spherical shape, then aggregation in spherical shape is called colloid or micelle. This aggregation of hydrophobic part towards the center of the sphere is called as micelle. So, that is how micelle formation takes place. So, that means under normal concentrations, the negative part is directed inward in the water, as well as positive part or hydrophobic part directed outwards, whereas at critical micelle concentration what happens is the hydrophobic part, they undergo aggregation, tails, they undergo aggregation to form a spherical shape of structure. So, in that spherical shape, the hydrophobic part, that is hydrophobic part to hydrocarbon chain, that hydrophobic part is directed towards the center of the sphere and forming the aggregation of these molecules, where the negative part is directed outwards. This aggregation of molecules is called micelle. That is how micelle formation takes place. So, that is the mechanism of micelle formation. So, idu micelle formation mechanism mugitu. Then last part idaralli cleansing action of soap ide. So, adanna ಮುಂದಿನ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ನೋಡೋಣ. ಥ್ಯಾಂಕ್ ಯು.